Today's video is sponsored by Native Sons Goods, makers of the highest quality woven guitar, bag, and camera straps you'll ever see. Native Sons straps are handmade one at a time in the USA with unparalleled love and care. Click the link in the description to check out their new expanded lineup featuring all new 3-inch guitar straps. And remember, when you support my sponsor, you support this channel, and I sure appreciate it. Hey, what is up, dudes and dudettes? Brad the Guitologist here, and we are going to get back to amplifiers today. I'm sure a lot of you will be very psyched about that. Here we go. We've got this thing on the bench. This is a Knight, let's see, this is a 35 MDX. I believe that is supposed to indicate the wattage on the output of this thing, the 35, and it does have a pair of 6L6s, as we will see momentarily. This thing was shipped to me by a gentleman who lives out on the West Coast, and the first time he shipped it without any tubes, and I had to contact him back, and that's another reason it's been here for a little bit longer than it should have been, because I had to contact him back and have him send me the tubes separately. So he went ahead and shipped those out to me, and I've got the tubes in now, so everything should be pretty much ready to go. We'll take a look at this. Well, first let's look at the front panel. We have over here on this side, we have a microphone channel up on top, another microphone channel down there. We have in the middle, we have a dual phono channel. So this is a stereo channel, and there's a center kind of detent here. So the more you go to one side, the more it's going to fade over to one side. So what this allows you to do is to have like two mono sources of music going at the same time. So you could have like a mono tape over here and a mono tape over here, or you could have like a phonograph and a tape on, you know, the other side, and then you could kind of DJ, so you could slowly fade from one to the other that way. We've also got bass and treble over here. Neat looking thing. I like the fact that it's got this decibel meter here on the face, so that's kind of cool. It is hooked up, so I don't, you know, we'll see if it works or not. Sometimes these things don't really work so well, or they don't work at all once they're of this age. We have a power switch here, and this is one of the clicky style. It's a rotary switch on the inside. But if we turn it around here, we'll see the rear of the unit, and you can see everything is pretty much exposed. We got the giant Coke bottle tubes over here. Again, two of these are 6L6. The rectifier, I believe, is a type. What is that? It's a type 83 rectifier. The thing I'm kind of skeptical about on this rectifier is it's kind of full of these flakes. You can see the little metal flakes on the rectifier there. So I'm definitely going to dial this up slowly. I don't know if that's metal flakes or if that's kind of flakes from the mica spacers that are just kind of maybe deteriorated somehow over time. I just don't know. We're going to be careful as we fire it up, given that. And then we have a weird kind of set of tubes over here in the preamp. We have a 6V6 in the preamp, and I'm not sure exactly what that's driving. I guess it's possible that it's somehow in the circuit with the meter, but I don't know. I'm not sure on that one. And then we got octal tubes here on the, and we'll take a look at a schematic here also. We've got a couple of, you can see the phono input there. We've got a couple of phono inputs back here. Here are our microphone inputs, and those are already 1/4 inch for us, so that's kind of nice. We won't have to mess with that. I believe this is an output, so that'll be a 1/4 inch output already for us as well, possibly. So that's another thing maybe we won't have to mess too much with. We have, this is kind of nice also. This you don't see on a lot of older PAs. This is kind of a really nice PA. We have an ohm selector switch here, so we can go from 500 ohms if we've got, you know, really long wires, and I don't know, like an installation like in a church or something like that, you know, and you want to just leave everything installed and you use a lot of speakers. You can tie them together and use these larger ohms like 500 and 250, but and for standard R purposes, for guitar purposes, we use the 8 ohm most likely, or the 4 ohm, or even sometimes the 2 ohm. But this does allow you to switch between 2, 4, 6, 8, 250, and 500, which is really nice. It's nice to have that switching, and it's also nice to have all those windings in the output transformer. That's really highly unusual. Well, I say highly unusual. It's not that unusual, but it's it's reserved for kind of the upper echelon of amps from this day. We have a big power transformer here. There's a fuse under here. I don't think it was blown. I believe that's a fuse. Yeah, that's a fuse right there that's not blown. And you can see also that it allows you to select between input voltages. So you can select whether you want to use the 118 to 125 voltage range, or if you want to use a bit of a lighter voltage range, you can move this over to here. So that's nice as well. That's another top end feature for a PA of this age. We'll have to look at a schematic first and see what is what we want to do, kind of lay out a game plan. So yeah, if that sounds like something you'd be interested in, please stick around. Okay, so here we go. We're going to take a look at the schematic that was sent along with this amplifier. I believe this is the correct one. At least it does say down here, Allied Radio Corporation, 35 watt Master DX amplifier. It looks to be correct just from my cursory exam. 1940 is the date on the schematic. So I'm assuming, this amp is definitely from the 40s. I'm not sure where along in the 40s it's from, but it's definitely 40s. And you could see this schematic has seen better days. I don't know where he got this, but in all of my searching, I wasn't able to find anything on this amplifier. So I don't know. Anyway, you can see microphone inputs 1 and 2 right here. If we scroll down a little further, you can see the phono inputs right here, or at least 2 of them. And then we have some kind of internal input here as well. I don't know if this is meant to be some kind of remote plug that we just don't have here. But this is really mostly what we're concerned about. You can see microphone 2 and microphone 1 each go into a 6SJ7, which is a pentode, and each of the grids are running vertical here in this drawing, which is not really that representative of the way that the signal, the internal structure goes, but it's probably just easier to draw for them for whatever reason. But you can see this is a grid leak biased amplifier. We have a capacitor going into the grid here. We have a large 2 meg resistor to ground for bias. And these 2 components work in conjunction with one another to bias this stage. You can see the cathode just goes directly to ground. This might be one area where we can improve upon this design. If we look at some of the early Fenders, we might be able to do something that's a little bit closer to something that Fender would have done. But a 6SJ7, this is going to give us a lot of oomph right up out of the gate here on this first stage. So this is a good tube. I'm glad to see a 6SJ7 here. It's just a good sounding overall tube, I think. That's a very small capacitor right there, that 0.005. That's a small capacitor for what I would probably put there, but I don't know. It may sound great though. And we may even just try this as it is, without doing any real modifications to it, just to see what kind of tone it gives us just out of the gate. I mean, obviously there's going to be some things that we can do to this to probably make it better for guitar, but a lot of times, man, you can plug into these PAs and they sound pretty good just out of the gate. But yeah, the fact that we have 2 channels here, this might be also an opportunity for us to maybe make one channel, grid leak biased, and then maybe the other channel we can do more of a cathode bias, traditional guitar amp sort of thing. Again, I'm not sure what is this 0.05 capacitor right here. That's a suppressor grid tied to ground. This is also tied to ground from the screen. So that's okay. That's kind of a smoothing capacitor for the screen. That might be okay. We may end up leaving that or fiddling with the value, or we may remove it altogether. I'm not really sure quite yet. But we'll kind of see what we want to do. First, we want to just look at the architecture here and what we're dealing with. This is a 6SA7 tube. And again, just another weird layout, the way they have this laid out. And it looks like it might have a couple of diodes in here. Like this might be one diode, and this might be another diode right here around this grid. That's what it looks like it might be to me. Not sure what the deal is with the remote jack. Okay, so what is this jack intended to do? Is this going to suppress? Well, there's 190 volts on this line right here. Let me look up the 6SA7. Let's see what this tube is. 6SA7. Okay, this is a HEPTODE. Jeez, it's a HEPTODE. We've got 1, 2, 3, 4, 5 different grids. Okay, so a couple of these are tied together. The second and the fourth grids are tied together to pin 4. I think those are the only two tied together internally. So that's interesting. That's an interesting tube. I'm not sure how that's going to help us much. And I'm not really sure how this is meant to be used here, or how they're using this. These are not diodes. So this is a grid, but it's just showing that these two are tied together here to this 190 volt supply. I wish it would give me the pin numbers to make it. That's going to make it. Would have made it a lot easier if they gave me the pin numbers on these. But our voltage is coming from down here, and let's see something here. I'm curious. Okay, obviously it is coming off of the power supply. I'm just wondering why there would be a remote jack here tied to this high voltage supply like that. I mean, I know it's got a 20K resistor right here, which is going to drop. It's going to drop the voltage some, but it's not going to drop it all the way. And I just don't know why it would be. I mean, because you got voltage. You've got a high DC voltage probably sitting right here on this jack pin. So I don't get it. What are they doing this for? Is that so this can power something else remotely? Like there's something else that needs power from this unit, so it gets its power from this? Well, it's tied here to the cathode of this tube. So what is it doing? Turning this off? Is that what it's doing? So when you lift this, it's lifting the connection to ground. So there, this tube will basically lose bias and turn off, right? So when this tube loses bias and turn off, it gives you, you can use the remote to do that, to turn that off. We're definitely going to remove that. We don't want anything to do with that. We may also bypass this HEPTODE. I'm not sure what we're going to do with that yet. It looks like the only reason they're using this HEPTODE configuration is because probably during the switching they don't want to pop or something, and they found that by using this configuration you don't get a loud pop whenever you remove the cathode. Maybe it has something to do with that. At the same time you're switching this thing off, you might be also removing the voltage, or seriously diminishing the voltage on these two grids or these screens. So yeah, that could alter the way the tube behaves to the point that it doesn't, pop. It doesn't make a loud pop when you flip a switch like that. But is this something that we're going to want to keep? I might completely rewire this stage here into something else. But look at this. We have this initial stage, then we have a volume control, and then it goes through this damn that's a half meg resistor into the next stage. Then we have an SC7 stage right here, which is a dual triode, and it looks like they're running this in parallel. Just a weird, this is a batshit kind of configuration. What are they? Again, this remote jack is probably the key to it all. And that could be, I'm starting to believe that the jack that we saw on the back of the amplifier that I thought might be the output jack, I'm thinking that might actually be the remote jack, this. So this will give us an opportunity maybe to convert this remote jack into an output jack anyway. So yeah, it's always interesting to just kind of see what they're doing on these old PAs. But that right there, again, that's kind of batshit the way they're doing this. It's like, so you've got both triodes running together, and then it comes out of that and goes through some kind of obscure capacitor right there, and then a small 0025 capacitor right there. Why they have two different capacitors, I'm not sure, but we've got another. It's got another offshoot. Oh, this will be our tone shaping network up here. This is our tone network. So that will be part of the tone network right there. More times, than not, tone stacks are kind of drawn down here. That's why just the way that they have this drawn too is weird. But this is in the 1940s, so this is before, this is 1940, so this is like before things really got standardized and people started doing things kind of the same, But here's the kicker, okay? Here's the real kicker right here. We have a 6F6G. It's not a 6V6. I thought it was a 6V6, but I was wrong. It's a same family of tubes. It's a 6F6G. You normally see 6F6 in output stages for things like old radios, but in this case they're using this as a driver into this transformer, which is serving as the phase inverter. You can see on this other side right here we have a center tapped secondary, and this gives us both sides of the phase. So this gives us the positive and the negative sides of that phase shift into the 6L6G Coke bottle output tubes at about 35 watts, so they claim. So the output is fairly standard, except for this 6F6G. I mean, it's a pretty big tube to be pushing through right there. This is a very interesting amplifier. And on things like this, I usually like to keep as much of this the same as I can, and the reason I like to do that on PA conversions is because it's just given us a different look. It's given us something that's different than what you could go out and just buy. If the guy wanted to go buy a clone of something, he could go do that. But this is going to give him something different. It's a conversation piece. He can bust out this schematic and talk about it with his friends and say, hey, this is why it's different. So I'm going to try to keep a lot of this the same. Now this 6SA7 we might have to do something with this. Like I said, I think it was only used because they were doing this remote jack switch right here, and they needed a special tube in order to do that, and they needed these extra grids to be able to suppress the noise and the pop whenever the remote jack was switched. I think that's why they have done that. Now, don't quote me on that, because like I said, sometimes I can look at this kind of stuff and I can sort of try to surmise what they were thinking and what might be going on. But I'm not an electronics genius to the point where I can just look at this stuff and it just materializes to me. It takes a bit of thinking about what they're intending here. But obviously you have a cathode bias stage here. So you have the cathode here with a cathode resistor, a bias resistor here, and then you have a bypass capacitor. So that's fairly standard, but then this should go to ground also, but it doesn't. It goes to this, it does actually goes through the remote jack to the ground through there. But you know what? If this is corroded, this point right here, if this thing gets corroded like a lot of jacks do, that's gonna really screw up this stage, and it may not even operate at all, and may make the amp do some really haywire kind of stuff. So it's that's a risk in and of itself to leave something like that in, even if we were to just leave it intact and not use this remote jack. It'd be far better just to tie this line right here directly to ground instead of going through this jack like that. You also have an opportunity here, it looks like. I was kind of thinking out loud here. What I was thinking is you could actually use the remote jack, and that would allow you to do some kind of switching right here. So you could have some outboard device that would put more resistance in series with this, or less resistance in series. So it would give you, a different gain structure on this stage, so you can kind of change things a little bit with that. But there's really no need to, because you've got a volume control. So you could put a volume control somewhere along in here too, like change this 250K resistor right here to a pot. That would give you a post control, a master volume. Maybe some other things as we go along will come to me, but let's, I'll tell you what, let's go ahead and open the amp up and see what it looks like on the inside. Okay, I was getting this bottom panel off so that we could open this thing up, and I found another jack over here on the side that I did not see before. And of course we have the license by Electrical Research Products. Western Electric and Electrical Research Products are both subsidiaries of AT&T, and all of this early stuff, man, all of this early tube technology was licensed by AT&T for the purpose of telephony, and it's just, they basically had a monopoly on everything. A lot of people think it was RCA that had the big monopoly on everything, but no, it's really AT&T. Of course, you know, RCA came along later and, you know, started really developing and getting into the markets and buying up a lot of stuff, and so they became a big one too. But the early stuff was mostly AT&T. They had a lot of the early tube patents. But yeah, I'm curious now what's up with this jack. So one of these might be an output, and one of them might be that remote. I'm also curious whether or not there might be a schematic on the bottom plate. Looks like there was another screw there that's missing. So somebody has been in here. God knows how long ago that was, but wow, look at this. Look at these big blue capacitors. What are these things? I've never seen these before, I don't think. What is this? Does that say shaver or braver? Beaver. No, excuse me. It says beaver because I could see it up here on this one.
Nice beaver.
Well, that's a new one on me. I don't think I've ever seen a beaver.
That's so very, very sad.
Yeah, I would say by the look of this jack right here, see the way they have this separated? So it goes way over here, and then it's separated. The wafers are separated over here on this piece. I would say this is the one that carries that voltage that we were talking about. Yeah, this is interesting, man. And I also have to wonder whether or not, like this socket right here, some of these, they won't turn on unless you have something in the socket, and that prevents you from burning one of these up. So that could be the output right there. So, and it looks to me like it is. That is the case, because our cord goes directly to that socket, and that could be, you know, like I said, a safety mechanism to keep you from turning this unit on if there's nothing plugged in here. That's going to be one of the big power resistors. But look how close, and look, this thing's just kind of dangling here and dangling a bit close to the transformer. It's not on it. It's just a bit close for comfort. See what I mean? I don't know. I mean, there's some room there, but it's not very much. But yeah, this is kind of what I expected. You know, this is sort of what I expected to see. A couple of surprises. These Beaver brand capacitors I've never seen before, so that's interesting. Here's another. Is that a resistor? Continental certified resistor. What the hell? Continental resistors. Have you ever heard of such a thing? Anyone in the amp community, have you ever heard of Continental certified resistors? That's a new one on me too. I've got two of them here on the input. And why would you want some kind of special resistor on the input? That doesn't make a whole hell of a lot of sense. And also, this input here on the side, that's an input, and it's tied in with the rest of these inputs over here. So that's interesting as well. Everything's shielded, at least, so that's cool. They at least made an attempt to keep down noise, but we've got all these wax capacitors. You see all these waxy capacitors. These are all going to be bad and leaky. I mean, I can almost guarantee it. So yeah, it's about half what I expected. I mean, a lot of these resistors are probably going to be way out of spec and everything else, man. We're just going to have to go through this and just basically start at the input. Like I said, we'll probably fire it up just for shits and giggles to see how bad it is, just as it is. But as far as leaving it in this state, yeah, there's a lot of work to do on this one, man. This is a lot. There's a lot of this that's going to go. And oh yeah, one thing of note, there is no schematic here. If there ever was a schematic, which it looks like there was at one time, and somebody tried to tape it on, but it's long gone. We can see the capacitors over here, the cans. This one has had a couple of the legs cut off, perhaps. And it looks like it might be leaky, physically leaky. This one's still connected. This one up here, you can see all this this kind of salty look. It's almost like sand or salt that's kind of squirted everywhere. There's a bunch of it there. There's a bunch of it over here on these wires too. It looks like it might have even gotten into that resistor right there, perhaps, at some point, and kind of eaten away at it. That's all electrolyte, and that's from probably one of those right there exploding out from that can. And you can see this one's been unhooked, and that one probably exploded. This one over here is still hooked up, but it's, you know, God knows what's going on with that. So, you know, we've got massive problems in this. The whole, I think all of the capacitors are going to have to be replaced, but instead of just doing that, it probably just needs to go ahead and be redesigned in the process. So, okay, I think I want to fire this thing up on the Variac and just bring it up very, very slowly and do some measurements. I believe we have some really bad capacitors in this. Yeah, I think the switch is just a suggestion of a switch more than it is an actual switch. So power switch is going to have to be replaced for sure. And now we're getting some voltages here. I'm just checking voltages around the rectifier at the moment. Okay, this is the AC side. This is the DC side coming off. Got about 20 volts coming off of the rectifier, and that's falling down. I'm guessing the rectifier is heating up a little bit. I've got some sound at the speaker. I'm up about 64 volts on the input. We're only drawing 0.3 amps, which is not bad at all, really. 20 watts is not bad. But man, we're dropping straight off on the voltage here. Just straight off the cliff. Alright, we got 34 volts right there at the choke. 32 on the other side of the choke and dropping. Yeah, voltage really shouldn't be dropping like this. I'm fairly certain we've got some bad capacitors in this. Really bad capacitors. Man, I hate the way they've put these in here. These are awful. That's only 250 volts. What kind of voltages are present in this amp? Is this that low of a voltage? I think this thing must have really low voltage normally. We got 37 volts, and I'm dialed up halfway right there. I would really hate to take out a transformer or something like that. So I think what we're going to have to do here is just stop. Not try to dial it up all the way and see if it's... I mean, I've got a little bit of sound at the output, but with as low as that voltage is right there, that's exceptionally low. Way too low to be doing very much. This amp would not amplify very much if I were to go ahead and dial this up. We've just got a lot of leaky capacitors going on here, I do believe. Okay, so I was going to wrap it up right there, but curiosity's gotten the better of me. I at least want to see what this thing will do. Oh, that rectifier, dude. That rectifier was glowing purple. Wow. Yeah, some of that's reflection from that display, but not that right there on top. That's not reflection from a display. Whoa, look at that. Holy. Look at that. That's crazy. I've never seen a tube light up like that. That's insane. Wow. Okay. That's a Type 83. Lots of noise. And signal. But you can hear the characteristic hum of some really bad capacitors. And I think we're going to leave it at that. We already know that much. Okay, so I got curious about why this tube might have been glowing like it was. And sure enough, this is an 83 type rectifier tube. It's mercury vapor. And the mercury is actually supposed to condense down at the bottom of the tube. There are some people who recommend taking these and putting them on your tube tester and firing up the filaments at 5 volts and just letting it cook for a while to get rid of the little flakes of mercury that are inside of there. And you can see the little flakes, all those little flakes of mercury down in there. Those should condense down into the bottom of the tube under ideal conditions, and you shouldn't have any of that mercury in other spots. Like we have some up here at the top actually, and there's little tiny bits of it just, you know, kind of all over the place. Yeah, this is gonna probably get a redesign of to some degree. I'm not sure to what degree yet, but we'll just have to see. So stick around for a second video of this, and this might end up being a long one. I'm not even really sure. We'll see. We'll see how it goes. But yeah, thanks a lot. Hit subscribe down below. We'll see y'all later.